3.2 Rational exponents. Rational exponents are fractions. That's what the word rational means in this case, and it's just a math notation. It can lead to confusion, just like some people don't really like negative exponents, and you know, it's just something that you have to deal with. So, for example, 5 to the power of 1 over 2 actually means that we need to think of this as the second root of 5 to the first. Well, the second root is usually just written as the square root, and 5 to the first is 5. So that's actually just the square root of 5. So a fractional exponent, okay, if the 2 goes to the outside as an index for the radical, and then the 1 became a power, so it's just a radical expression. With the radical just meaning that, you know, it could be a square root, but it could be a third root, it could be a fourth root, etc. So this is a radical, and then that could be any number. So how does that work for here? Well, if you do enough of these, then you know that this is just the square root. It's the second root of 25 to the first. Well, the square root of 25 is 5. What about this one? I think I should have given myself a little more room. So this 4 to the power of 3 over 2 is the square root. So that's the second root of 4 to the third. Well, that's the square root of 4 to the third is 64. So the square root of 64 is actually 8. Okay, that would be one way to do that. Or you can do it this way, 4 to the power of 3 over 2. Well, keep in mind 4 was 2 squared, right? So then you get 3 over 2 here. These powers multiply because the exponent on top of an exponent multiply. So that 2 cancels with that 2. That becomes a 2 cubed, and 2 cubed is still 8. So that would be another way that you could do that. You can have them on variables as well. So x to the power of 3 over 2 means the second root of x cubed. If they already have exponents, then you can use, you know, the multiplication properties there, because what I just mentioned above is that if you have an exponent over here already and you have another one over there, the answer to that would be the multiplication. So it would be 2 times 3 is 6. Well, so you can do that with this as well. So 2 times a half is what you get on that one. And then y, you would get 4 times a half. And then on z, you would get the exponent that you don't see is 1. So 1 times a half, well, that's just a half. So I'm just going to write that one right away. Well, 2 times a half is actually 1. So that simplifies. So that's an x to the first. Times 4, half of 4 is 2. And then times z to the power of a half. So that is now simplified. Clearly, mathematicians like to tease people a little bit because a lot of problems are just set up to see if you can do these things sort of quickly or efficiently. So let's look at a couple of those. So one thing that you can do then, and this combines negatives and radicals, or rational exponents, and that is, you know, set up problems like this. Well, one way that you can solve this is the negative exponent means that you really should have had a fraction. So you could think of this as 4, and then you can make it a positive exponent by changing it, because in this case, you know, it was in the numerator, now you're shoving it in the denominator. And then you can work on that expression. So 4 to the power of 3 over 2 would be the same as saying the square root of 4 cubed. Well, I think we just did this, but we'll do it one more time. So that's the same thing as the square root of 4 cubed was 64, right? And the square root of 64 was 8. So this actually is 1 over 8. So that's one way to do that problem. The other way that you could do that problem would be to think of 4 as 2 squared. So if you think of that as 2 squared, and then use the power property, so that one cancels with that one cancels, so that leaves you 2 to the negative third. So this means that you actually have, that is 1 over 2 cubed. So the negative exponent does need to be dealt with at some point, and 2 cubed is 8, so that's a second way that you can do that. You just need to play around with these enough until you feel comfortable with it. Okay? If you're already given a fraction, then the negative exponent is really not a big deal. The negative exponent means that you can just flip your fraction. So sort of the same thing that I did over here. The negative exponent meant that instead of having the 4 in the top, I put it in the denominator. Well, in this case, I need to switch both of these. So you could just rewrite this as 81 over 100, and now you don't have a negative exponent anymore. And then the power of a half represents the square root. So what is the square root of 81 divided by the square root of 100? Well, both of those you can take, so that's actually 9 over 10. Okay, a couple more of those. We'll see what else we can do. So what about this? Well, that's a decimal. Yeah, but decimals can be written in fraction notation. And then 1 over 3 means that you take the third root of 8 to the first, which is just the third root of 8. So I'm not going to rewrite the 1 over here. The bottom, you also need to do it. So what's the third root of 1,000? Well, in this case, both of those exist. The third root of 8 is 2. Again, because 2 times 2 times 2 is 8. And the third root of 1,000 is 10. And then that simplifies one more time to 1 over 5. But what if you have a mess like this? Well, keep in mind, this just says you're multiplying a bunch of stuff, right? And multiplying can be done in any order. So the first thing that I would do is I would rewrite this so that I'd have all the numbers first. So this actually just says 2 times 4 times x to the power of a half times x to the power of a negative a half. 2 times 4 is 8. When you have like bases, which you do, you can add. So what is a half plus a negative 1/2? Well, that's 0. This is 8 times x to the power of 0, and anything to the power of 0 is 1. So this is just 8. Okay, so that one wasn't too bad. Next one's a little more annoying because now you actually have this exponent, so it needs to be distributed first. So this 9 actually has an exponent of a negative 1/2. And then this one has a 3 already, so 3 times a negative 1/2 is a negative 3 over 2. And then the same thing over here, that's a 27, so that 27 is going to carry a negative 1/3 as an exponent, and then x to the negative 3 over 2 times a negative 1 over 3, because I need to distribute this over here. So let's see what this means. 9 to the power of a negative 1/2 means that it should have been 1 over, and then that's the half becomes the square root of 9, times, now bring the 27 over, because I want to do the numbers first. So this, negative 1/3, so I'm going to do this in steps on this one, because we haven't seen a lot of cubes. But that first means that actually could have been written as this, 1 over 27 to the 1/3, and then the 1/3 gives you a 1 over, so that's the third root of 27 to the power of 1. So all of that just to say that this is the cube root of 27. And then I get a negative 3 over 2 with an x. So that's this one. And then here, let's simplify a little bit, and a negative times a negative makes a positive. So it gives me one other x, and then the exponent for that is a half. But the square root of 9 is 3, so that's 1 over 3, times the cube root of 27 is also 3, so that's another 1 over 3, times x, and the negative 3 over 2 plus a half is actually negative 2 over 2, so that's a negative 1. So 1 over 3 times 1 over 3 is 1 over 9, and then this should have been a 1 over x, so I'm going to put this as one fraction. This is 1 over 9x. Okay? Well, I know there are different ways of doing most of these, so if you did it a different way and you still got 1 over 9x, I think we're on the same page. But this is just what I saw and how I would have solved it. Thank you.